going on,
What's up,
man?
man? How's it going, Alec?
It's going pretty good.
Hey, did you hear about the Patriots and them cheating and all that stuff?
Oh, come on, man. They didn't cheat.
Oh, for sure they did.
Yeah, but, like, the mass doesn't affect the velocity of the ball.
I'm pretty sure physics will tell you otherwise.
Well, let's test it.
All right, let's go. I'll prove it to you.
Okay, so I bet I can throw this through a hoop. Do you have anything?
Oh, of course I do. All right, so I'm going to put this approximately a meter above where you're going to be throwing it at. I'm throwing it at a fixed angle, and we're going to find the velocity right when it's at the top of the hoop.
All right, let's do this.
All right, let's go.
Two 2,000 years later.
So much later that the old narrator got tired of waiting and they had to hire a new one.
That's probably enough.
Tom Brady style.
Are you recording it?
This is what Tom Brady felt like.
And
A
then keep on.
deflated ball. See, the mass doesn't change how you throw the ball at all.
Man, how about we just take a physics look on it?
Fine. So this is the total energy equation, which I'm guessing is what you're going to use to prove that the football depends on the mass. Alright, so let's start out with the normal mass of a football is 0.43. That's a fully inflated football. We're throwing it to a height of 1 meter, and the velocity initial is going to be 15 meters per second. Alright, so first right away you can cancel out potential energy because the original height equals 0. So that leaves you with this. Now, when you plug the numbers into that, you end up getting 48.375 on this side and 4.2183 plus 0.215 with the velocity initial squared. Alright, so after you subtract this, divide by this, and take the square root of all, you end up with 14.3 meters per second for your V final. Alright, so now if we change the mass to the mass of a deflated ball, we get pretty much the same velocity as you'll see later. So first you can still cancel potential energy and you use the exact same equation, and after you plug it in, you end up with 14.3 meters per second for the velocity. Now that's exactly the same. However, the amount of energy to throw the ball, because of the smaller weight, makes it much easier to throw the ball for Tom Brady. Now, if we look at this through a different lens, we can see the exact same thing.
All right, so cool. We came to an agreement. And just one more way, in case you weren't convinced, is use kinematics. So this is the launch angle, 17 degrees. Velocity is 15 meters per second, and the change in y is 1 meter. This is where we have the belt at the top of its trajectory, and here's the 0 line. So because of trigonometry, we see that the initial launch it makes a triangle. So because of cosine equals adjacent over hypotenuse, we come up with the velocity in the x equals 15 meters per second times 17 degrees, which gives us the same velocity as it did in conservation of energy.
Alright, well, I guess you are right. Tom Brady is a cheater.
Told you, man.
Hey, at least we got the Packers to,
Exactly, I was thinking the same thing.